Here we will be discussing about some of the important graphs which you should remember. Okay, so let me just start by general function. Okay, so we know that the functional form looks like this: y equals to f of x. Now, in general, if we try to plot this, and we have done this earlier, then it looks like, suppose this is the y-axis, this is the x-axis, then the curve in general it may have a look like this. Then this is the graphical representation of the function. Graphical representation of the function. Okay, now in reality, if I have some function like y equals to x, y equals to x square, y equals to x cube, y equals to e to the power x, y equals to sine x, y equals to cosine x, y equals to tan x, y equals to cosec x, y equals to sec x, y equals to log base a, and it is operating on the x. And suppose we have some formula, or rather to say some functional forms like these, and y equals to cot x, and so on. So these are some real examples of functions. So if we try to plot them, then how does that look like? Before that, you know, and I have discussed this, you know that how to plot a graph. Y equals to f of x. For some value of x, I will have some value of y. So if we try to plot each point, then we will have some sort of like this, a curve. So now if we just connect the all points, then we will have a curve, which is the functional curve. Now let me just start one by one, and I will ask you to remember these. Actually these are very important, and we will see the application of these in almost everywhere, in every chapter almost. So I will suggest you to remember these curves. How do they look like? Okay, so let me start by y equals to x. Okay, so if I plot, this is the y-axis, this is the x-axis, and the here if we plot this function, we will get something like this. Okay, and this will be extended, I mean, in both sides, and this is the this. Okay, this is the functional, you can say the graphical representation of y equals to x. So what we can see, so this is a straight line, this is a straight line, and this straight line makes angle 45 degree with the positive x-axis. So if now I ask you what is the slope of this, then we can say that as this is a straight line, the slope will be constant throughout the curve, and this will be tan theta, and here theta is the angle which the curve makes with the positive x-axis. So here theta is equals to 45 degree, and you know that tan 45 equals to 1. So here the slope is 1. Okay, now I think you know very well that this is the origin, so the coordinate of this is 0 comma 0. So if I just suppose this is the 1, so obviously as y equals to x, so for x equals to 1, y will be what? Y will be equals to x, so y will be also 1. So I mean the curve will have some points like this, and actually this is the, I mean, the first of all we should be doing this, then we should plot the graph, I mean just draw the line. But here the important thing is to remember these curves, so I'm not doing this again and again. I think you know, because I have already discussed how to plot the graph, so I think you can do this by yourself. So for now, just try to remember whatever I'm saying. The next is y equals to x square. Again, the y-axis, the x-axis, and the curve. Here we will have some sort of parabola. Okay, some sort of parabola. Okay, this. So this is the origin, and this is the graph. I mean here at x equals to 1, suppose this is the x equals to 1, then what will you get? Y equals to x square. So x equals to 1, that means y equals to 1 square, that is 1. So for x equals to 1, this point will be 1 comma y equals to x square, that is 1 square, that is also 1. So for x equals to 2, I will, if I just extend this graph, then I will get y equals to 2 square. That is, for x equals to 2, I will get y equals to 2 square 4. So in this way you can just uh, understand this graph, but the main thing is to remember this. So this is a parabola, this is a parabola, and here you can say that this is a curve. So the slope is not constant. The slope is not constant. If you have not seen my earlier videos, then I think you should have a look on those, because I have discussed all in very details. Okay, fine. One playlist is already made, so I will suggest you to uh, go step by step and follow the playlist. Okay, the next graph. The next graph is y equals to x cube. So here, let me do this again. This is the y-axis. This is the x-axis. And here the graph looks like something like this. Okay, so this is the y equals to x cube, y equals to x cube. So again, this is a curve. So the m will not be constant. I mean, okay, you can understand what I want to mean. Let me go to the next, that is y equals to e to the power x. Again, let me just draw the y-axis, draw the x-axis. Here the graph looks like this, not this, this. So what will be this point? You can very easily say here x equals to what? 0. So y equals to e to the power 0, that is 1. So this is the 0 comma 1 point. And this, okay, you need to understand that this graph never touches the negative x-axis. It will just go near to negative x-axis, but it will never touch the negative x-axis. And okay, fine. So here also this is a curve, so the m will not be constant anymore. Here also the m is not constant. Let me go to the next one, that is logarithm. So y equals to log base a, which is operating on the x. Now here there are two cases. So here there are two cases. The first case is when a is less than 1, when the base is less than 1. Then the graph becomes, let me just draw, this is the x, y. Then the graph looks like this. Okay, not like this. Let me just yeah, this will go like this. So we say that this is monotonically decreasing. Okay, here this point, can you guess? Okay, here you can see that the y is 0. Okay, fine. So the y is 0, and we know that y here is, okay, when the y will be 0, when the x will be 1, we know that log of 1 is always 0. So here we can say this is 1 comma 0 point. Fine. Next is, okay, the case 2 of the same log x, case 2. Case 2, here a is greater than 1. So the previous case, a was less than 1, here a is greater than 1. Then what happens? Let me try to draw this again, the y-axis, x-axis, and here we say, or we see that, okay, let me just try to plot this in a better way. You can see that this is increasing here. Here also this is 1 comma 0 point, and this is again a curve which is monotonically increasing. Okay, in these both, this will go towards the y, but it will never cut the y-axis, and same goes for here. Here also this will never cut the y minus y-axis or negative y-axis. Okay, fine. Now the next is y equals to sine x. The next is y equals to sine x. You know that the value of sine x, the maximum value can be 1 and the minimum value can be minus 1. So here if we try to plot y-axis and x-axis, then the graph looks like, so here is the 1 and here is the minus 1. So if we just fix the barrier here, 1 and minus 1, because the graph cannot exceed 1 or it cannot go below minus 1, and the graph looks like this. You should try to remember this all, whatever I'm saying now. And this is the graph of sine x. You can this will be actually properly sinusoidal or wavy. So this is the graph. So here this is the point, the x is 0 here. Here x is what, pi by 2. Here x is pi. Here x will be 3 pi by 2. And this is similar here. This is minus pi by 2, minus pi, and goes on. Okay, so this is the graph you should remember for y-axis sin x. Again, I'm not saying again and again that m will be constant or not. Obviously this is a curve, so m will not be constant. It depends on the position of the curve. The next is y equals to cos x. So here you know very well this is similar. I mean the range is similar here also, -1 to 1. So again, let me draw the y-axis, draw the x-axis, and we have to set the boundaries here. So let me just say that this is 1, this is -1. So let me just set the boundaries. Okay, so this is not the graph, I'm just setting the boundaries. I'm just setting the boundaries. Okay, so just little bit modification because this is not okay. So now this is 1 and -1. So now here the graph looks like this. Here at 0 there will be 1, cos of 0 we know that that is 1, and that graph goes like this. That graph goes, oh, it's properly wavy. Okay, that graph goes like this. There is no cusp. This is smooth. This area is smooth actually. All a smooth area. This is smooth area. Where this is x equals to 0, this is what, x equals to pi by 2. We know the cos pi by 2 or cos 90 degrees is equals to 0. So here it is pi. Here this is 3 pi by 2, and here this is minus pi by 2. Here it is what, minus pi, and goes on. It goes on. Okay, fine. Next is y equals to tan x. Y equals to tan x. So we know that tan x can take any values, any real values, from -infinity to +infinity. Okay, so here we just want to plot this. Here is the y-axis, here is the x-axis. Okay, this is the x-axis, this is the y-axis. Now if we try to plot this, the graph becomes something like this. Okay, and here let me just for reference draw some dotted lines. These are only for reference. Why am I drawing this? You will get to know in a moment. So again this repeats itself, this repeats itself, and this will be repeating throughout the x. I mean this is a periodic nature, this is a periodic nature, so this will be repeating, and this is again a reference, and this is repeating. This is repeating just like cosine x, sin x, these all are repeating. So here the blues are the curve. Okay, so here these lines what I have drawn here for reference to show you that this curve will never touch this line. This curve will go but will come closer but never touch this line. And this is x equals to 0. Here x equals to pi by 2. We know that x equals to pi by 2. Tan x is not defined. X equals to pi, and here also similar, minus pi by 2. Okay, and here pi. This point is pi, minus pi. The same goes for this, never touching. Fine. Okay, so obviously m is not constant, you can see from the graph. Now there is some discontinuity. What a discontinuity? Look at this. At x equals to pi by 2, the curve will be near this line, and after just passing x equals to pi by 2, that it suddenly drops to this point. Are you getting my point? So this is not like normal continuous curve. This is something like this, suddenly drops and starts like this. Okay, so this is the discontinuity I want to mean. So yeah, try to remember this graph as well. Next, there are some more graphs which I will be covering in the next part. Try to remember these all graphs. Okay, bye.